Hi, I'm Don Cohen from Michigan Metrology. I've been in business about 30 years, where I've been helping people solve problems related to squeaks, leaks, friction, wear, appearance, adhesion. I work with Bruker Corporation as a value-added partner here in Detroit, and I have this wonderful machine called an NP Flex optical profiler that measures surfaces in 3D. So we're able to look at surface texture in great detail. We're able to put large parts underneath and heavy parts on there. And we also have this long working distance objective lens, which allows us to be fairly far away from the sample. Today I'd like to talk about an interesting part, and this is a gear. Gears are a challenging thing to measure. The gear teeth and their surface roughness has a play in the friction. Also, the surface roughness of the gears play a role in the pitting fatigue. But the trouble with measuring gears is it's very hard to get a stylus in there. The physical tip may not be able to get between the gears. It's a very sloped, steep surface, so it's very hard to get to. In some cases, we're able to use the NP Flex and tilt the part and just get enough light down in between the gear teeth. This happens to be one that just can't quite be done that way, but we do have a way of measuring these kinds of surfaces, and we use a replica process. And so in the replica process, basically what we do is we squirt this particular material that flows on the surface. And as it flows on the surface, it makes a replica of the surface texture. It takes 10 to 15 minutes to set up. You peel it off. And it's quite remarkable how well it can follow that surface texture, literally into nanometer kind of level. This happened to be a powdered metal surface. They produce surfaces that have a porosity to them. And that porosity kind of is a great place to hold lubricant and trap debris and so forth. So we went ahead and measured these by using the replica process. As you can see on the screen here, the microscope is in focus on the replica material. I'm going to move my microscope up a little bit. And as I move the microscope down into focus, we see this twinkly pattern come across. We'll get these fringe patterns that you see here. And as I move down a little bit more, this part of the surface is in best focus. And so what happens is the microscope will start scanning this from the top down, and we'll see that fringe pattern sweep across the surface. And once it's done scanning, it'll get to this screen where, again, red is high and blue is low. But again, let's remember this is the replica. So if I want to actually see what the original surface looks like, I have to invert the surface. And so this is actually what the real surface looks like. We see some very dark blue areas. These are the actual pores. We're able, with the software, to do a lot of interesting things. Move the cursor here and tell you how deep that pore happens to be. But then there's some more advanced analysis tools. The software package called multi-region analysis can set up a criteria that says, hey, I want you to find all the valley structures that are 3 microns or deeper. They have to have an average region size of 500 square microns. And I want you to just show me all of those regions and tell me what's their effective diameter and what's their volume. And then it can tell you for that particular pore what the volume is. And it's done that for each of these little porosity features that it finds, and then gives you a grand average. From a gear point of view, a little bit of porosity may be good because that may allow a nice area for lubricants to be entrapped. If you have too much porosity, you might be creating a surface that might fatigue and break and crack. Measuring gears like this is a challenge. With the 3D instrument, and particularly the replica, I can get into some pretty challenging spots. And what I've done is produce these 3D maps for people, and I provide the raw data. They're able to import that into their analysis software and actually simulate gear teeth mating against each other, what the areas of contact would be, what the friction might be, what the predictions for wear might be. As I mentioned, I'm here to help people solve problems related to friction and wear and surface finish. Feel free anytime to visit the website, to set up a meeting via Teams, and we can meet and discuss your applications. If you're in the Detroit area, feel free to set up a time to come by and visit, bring some parts. And again, just feel free to send a few samples in for no charge. I'll take a quick look and see what we can do.